Have you seen Science City Aquarium? Hmm? Or have been to IIM Udaipur? Civil Hospital? चलो Palladium also देखा ही होगा, है ना? Now, do you know who is the one responsible for making sure there's all these structures stand tall? Well, today we are going to meet a through and through engineer who lives, breathes and eats structures and structural engineering. Welcome to Real Estate Real Insights by Swati Procon.
Thank you so much.
Glad to have you, Utsav.
Glad to be here.
I was excited to meet you personally because looking at your body of work, what you exactly do, I would love to know more about what exactly structural engineering is.
So it's very hard to explain what we do, but it's also very simple. So there's a simple analogy, and I think I can explain through a human body what we really can do. So the skin is essentially the architecture. The veins, the arteries, the muscles, that's the mechanical, electrical, plumbing. And the bones and the skeleton, that's structure.
Wow.
Now, I mean, God, of course, is a great structural engineer, but I mean, I think human body teaches us essentially what we are supposed to do with the buildings.
Yes.
And broadly speaking, if wind comes, if earthquake comes, if you end up jumping on this floor, it's my responsibility to ensure that the slabs, beams, columns stand.
Yes.
And essentially, that's what I do.
Yes.
Yeah. I make sure that things stand when any kind of force comes on it.
Yes.
Yeah.
And from a human body perspective, we understand how important the bone and the structure is in my body. How did the journey start? You knew you wanted to be this as a child?
So, I mean, my first site visit, so I'm a second generation structural engineer.
Okay.
My father is a very renowned structural engineer. And my first site visit that I did was in grade 4 or grade 5. As I remember sitting behind my father's, scooter and going to check what he actually does. And he was very passionate about structural engineering, and he kind of wanted me to kind of see what he does.
Yeah.
Essentially, that was it. He kind of insisted that I just see what he does. And since that time, my passion for...
You remember that moment?
Yeah, of
Remember
course,
the date?
vividly. I mean, and distinctly, I would say.
Yeah.
That's something that I still tell my kid and my brother and my wife. That's a story that kind of stays with me, because that's where I started as an engineer. But then I kind of felt that was my calling.
Okay.
And a lot of times I've seen that what a father figure does for you, or what a father does for you, I mean, or what he does as a profession kind of influences a child as well. It's not that this industry or this field had a lot of money and so this is the natural progression for me. That was never the calling.
Which means there's a lot of money.
You'd be surprised. You'd be very surprised to really learn the numbers, but that's for another day. I would say. But then, as I grew up, I felt more connected with pursuing architecture. I kind of wanted to get into architecture because I was quite good at drawing. I was quite good at sketching. I gave my entrance exam at CEPT. I got selected as well. But then I also, got selected for civil engineering in Nirma University. And then my father felt that I should pursue civil engineering.
बड़ी दुविधा हुई होगी तभी आपको.
Yeah, I was...
CEPT and Nirma, or you wanted
No,
to
I was disappointed for good 6 to 9 months that I, kind of got myself persuaded by my father to get into civil engineering rather than structural engineering or architecture.
But good decision now?
Oh, in the hindsight, yes, absolutely. I mean, that's where experience really counts, right? Like, but then I did feel, a little grieved back then, but then
Destiny had bigger
exactly
things.
destiny, right?
Yes.
That's a great way of putting it. That was the destiny. And so I went into Nirma, did my civil engineering. After the first 2 years, I was kind of okay with the decision.
Yeah.
Yeah.
Lovely.
Yeah.
उत्सव, जब हम ऐसे आधी कंस्ट्रक्शन की हुई बिल्डिंग्स देखते हैं
Yeah.
तो व्हाट डू यू कॉल दैट, सलियास दैट यू
Yeah.
सी, लोखंड के सलियास,
हाँ जी.
दैट्स योर थिंग,
That is one of my things. Yeah.
वन ऑफ माय
That
थिंग्स.
is-
और क्या क्या होता है, एक आम इंसान जो कंस्ट्रक्शन से कोई रिलेशन नहीं है, जिसका तो
So I mean, you'd be fascinated to know that even our economists, even our finance guys, even the common people, they use the word structural a lot. One should have structural changes. One should have fundamentally or structural modifications in the economy of India.
Yes.
Right? Why do they use structural and why not architectural? I mean, it's a way of looking at it. Basically, it forms the most important core of anything to stand on. Structural essentially means that. Now, for a common man, if he passes through, goes through a road and sees, okay, there's something coming up, until and unless he sees some skin being kind of tapped onto it, it's all structure. And of course, there's a huge role for the architect to also play in ensuring that what is being built is right and is good. But then a large part of what you see when something is coming up is all structure.
आप लोग जब ऐसे डिस्कशन टेबल पे बैठते हैं, देयर आर्किटेक्ट्स, देयर इज बिल्डर, देयर इज कॉन्ट्रैक्टर, इज यू, ऐसे सब साथ में बैठते हैं ऐसे सब?
Do, yes, absolutely.
तो फिर डिफरेंसेस, ईगो इश्यूज सबसे ज्यादा किसके साथ होते हैं, या ऐसा नहीं होता?
I mean, again, with experience, you kind of learn to manage your own ego and manage others' ego as well. So I think that's a very important part of having an experienced personnel with you.
Right.
And yes, there are a lot of larger egos everywhere, and not just in architects or in developers or in contractors, but even within structural engineers, right? Because we are one profession. I would still want to believe that we are one profession who still works very much for and on the passion, and not really for the money. To say
Is
that,
it?
yeah,
What do you feel?
yeah, I still believe that, and I dare say most structural engineers in India would kind of agree with me on that.
And I wanted to ask you this. If I compare your profession to a film industry, so there are, actors, सब मेहनत करते हैं. There are cinematographers and the assistant directors and directors and actors. Actors को सबसे ज़्यादा mileage मिलता है because वो सामने कैमरे के दिखते हैं. You are absolutely behind the camera. So do you think, but still play a very, very vital role here? Imagine, lives depend on it. जितना importance मिलना चाहिए as an industry, as a sector, उतना मिलता है? Or it needs more?
Again, I've heard architects saying the same thing, that they would want to have more than what they're getting. I've heard developers still saying that they would want more than what they're getting. So essentially,
ये लोग को थोड़ा मिल रहा है, लेकिन I think it's like a film. राजेश खन्ना के time पे it was only the actors who've been talking about directors, पता नहीं होते थे. But now people know the builders. We also talk about architects. So I think structural engineers.
I think we are slowly getting our recognition. See, again, it depends on how educated the general public is also getting, right? Like regarding what we do, and it has taken, I think, 25 years since the 2001 earthquake to kind of have that, I dare say, but storytelling about everyone's role in creating where we are sitting, in creating every single entity that stands. And as a part of that narrative, as a part of that storytelling, we've also gotten some degree of recognition, to the extent where our field is respected. And I always insist on people acknowledging that structural engineering is a noble profession.
Is it?
It's a very noble profession. It's a very understated profession.
Yes.
But the work that the civil engineer and the structural engineer does for the nation.
Is it the same work, civil engineers and structural?
Well, there is a difference, but a structural engineer essentially still needs to be a civil engineer.
Okay.
I mean, a civil engineer can eventually become a structural engineer, but not all civil engineers are structural engineers.
And there is nothing like a structural engineering degree.
There is.
Oh.
It's a master's part of it.
Okay.
So you basically do your bachelor's in civil, and then your master's and your PhDs in structural engineering,
Right.
and so on. Yeah. So it's a specialized entity or a specialized subject beyond civil engineering. So basic civil engineering knowledge has to be there.
Got it. We got to know that you must have done more than 2,500 projects across Gujarat. Am I right?
Across India.
Across India.
Yeah.
Do you have any particular experience that must have really tested your patience or challenged your skills and still you came out winning? Do you have something like that to share with us?
Again, there's a very philosophical answer to this because there's no right answer to this, right? And I think, again, this stands true for every structural engineer and every architect. The challenge keeps on varying with your experience,
Okay.
right? So when I started in the field, say 17, 18 years ago, my challenge was to just understand what I need to do. And even a simple calculation kind of posed a nightmare for me. Subsequently, then after a few years, when I learned the basic things, I realized, now handling architects and their expectations, it's a very challenging thing. Then came a phase where learning how to manage egos, right? You just asked me about that. That was a very challenging thing because I suddenly felt I knew everything, right? And that's again, there's a phase where you know everything, and then there's a phase where you suddenly start realizing that you know nothing. And every engineer kind of goes through that. And today, if I have to say, a large part of my challenge is not really a project. A large part of my challenge is to ensure how do I build it right, and how do I ensure that I build optimally? How do I ensure that I bring in innovation into my project? How do I ensure that the tenants who come and stay in the flats and residences that I design feel safe and are able to use that place to the best of their ability and to convenience. That broadly summarizes the challenge levels as one grows in experience. Now, if you ask me what my father might be feeling as a challenge today, his challenges would be completely different than what I am or I might be facing. Running an organization is also a massive challenge. Running an organization of say 120 structural engineering team, it's a fairly tall task.
Yes, I wanted to talk about that as well. Quick one. Managing people, team is more difficult than the actual work, or sometimes the
100%.
100%.
100% managing team and managing work is 100% more challenging
Than the
work.
You spoke about innovation.
Yeah.
We'd love to know what new technologies or innovations are you getting in your work?
Yeah. So, see, in the field of structural engineering, India has a lot of catch up to do, to be very honest.
Okay.
I do feel that there are phenomenal structural engineers in India, but then in terms of application of new technologies, India has just started that journey of adoption. So I'll just give you an example, and again it's something that I need to kind of take it with a small story. So I was designing a very large, probably the largest media house in the northern part of India for a very renowned media house, and they call it one of the largest media houses in Asia. That's what we designed. And the mandate to us was that, Utsav, I need to get this building with the interiors ready within 1.5 years. And I, being a media house, I need to be operational even post the worst of earthquakes. And how do you build fast? How do you ensure you get the best of seismic performances? And that too under...
What is seismic performances?
So basically earthquake,
Right.
is what we define as seismic, right? And Earthquake, obviously, in the northern part of India is one of the most, critical aspect of design and forces that we as structural engineers have to ensure
Yes.
and incorporate in our design.
Yeah.
So I kind of told him a very simple story that there are, two ways of taking care of earthquake, seismic. One is to resist it. One is to absorb it.
Yes.
The conventional way of doing the work is to resist it.
Yes.
That's what 99% of India is currently doing, resisting the earthquake.
In terms of the
Shear walls. So we basically introduced large-scale shear walls, RCC, reinforced concrete shear walls, to resist the earthquake.
shear walls, as in Utsav, if we can.
So really long concrete walls, which kind of are thick walls built with a lot of reinforcement. And then when the earthquake comes, they kind of hit the building
Stand and
right, and not just fall over or lean over. And that's why shear walls play a very critical role in getting
those are thick, heavy walls.
heavy walls.
Okay.
Made of concrete.
ठीक है.
And those are the resisting entities. 99% of the structures today in India are for earthquake resistance. Shear walls
ठीक है.
is the way.
But
then they do take a lot of time. They do take a lot of effort.
Okay.
And it's not very fast and easy to build.
Okay.
So we kind of adopted, the other way of kind of handling, absorbing. So how do we absorb? And so I had to kind of again tell the gentleman a unique story that because he's not a civil engineer, he's not a structural engineer. So a story kind of starts with when I was very, very young, there was a mythical car called Mercedes-Benz. And the story goes that if there was a glass of water to be kept on the backside of the back seat of the Mercedes-Benz, and the car rolls over a bump, the glass wouldn't even fall, spill over or move, right? That was a mythical story.
Yeah,
all of us would have heard that. So how does that happen, right? Like it went through a bump and the glass didn't even topple. So what happened? Did the energy of the bump not go through to the glass? Said, okay, shock absorbers, jumpers, all those things in the car, right?
Yeah.
Said, yeah, exactly. Got it. So you have the answer. That's what we're going to do for the building. We're going to put shock absorbers.
कैसे?
Dampers. So a bump to a car is earthquake to a building. Right? And that kind of made some sense to him.
Yeah.
And he kind of, started understanding. We kind of gave him some examples of how it kind of works.
But that's where technology is involved.
Exactly.
Yeah.
Right? So dampers. And we started, exploring that option, and that required exhaustive analysis because nobody had really done it. Right? And that was probably one of the first, second or third building in India in steel structures where dampers were being used.
You did that?
Yeah. And we got it kind of vetted with different IITs and kind of the proprietor of the media house kind of really wanted a lot of validation on what we were trying.
Experimenting in his business.
Absolutely.
With the convection, of course.
Yes, and that was his question. That also, while you are experimenting in my building, I do take into consideration that it's only to ensure that it's better.
Yes.
Right? And that required a lot of validation.
Yes.
Right? And for us also to be able to kind of do it with a lot of, confidence, we had to...
But how's it now after years, the technology?
It's performed well. We are using kind of the same technology in a couple of other buildings as well right now. And I keep, so one of my roles today within the organization and even outside it is to kind of always be available to people and to developers and to architects and to industrialists about what kind of innovation, and the futuristic technologies that probably India needs today as we are, our economy is expanding, our growth is expanding at a neck break speed, right? And for us to be able to kind of sustain with that speed, we'll need innovations.
What next innovation? Something interesting. अगर आप अभी use नहीं भी कर रहे हो, क्या आने वाला है अगले 5-10 सालों में?
See, I mean, not just in structural engineering per se, but I think I do feel that, like I told you, a large part of my daily challenges is managing a team, managing resources, managing projects, right? And so I do feel very strongly that the innovation would probably come in the form of how we look at engineering things by using AI.
Yes, so systems are going to come and in all the industry, but आपका जो काम है ना उसमें innovation कैसे ला सकते हैं? मतलब वो सबसे ऐसा लग रहा है कि आपकी industry थोड़ी दूर है in terms of innovation लाने में.
Yeah.
Rest everywhere we're using somewhat of ML and AI.
Absolutely.
But आप में क्या? And you see in generally infrastructure, building में अगर सामान ऊपर लेके जाना है, cranes लगाने हैं, ये वो हर जगह बहुत सारी technology.
A lot of it.
आपके यहाँ क्या मतलब material?
So all of that, the contractors, and the developers keep adopting these new technologies, and I think in all those technologies we do have a small role to play. I think in all of them.
Right.
But having said that, in terms of literal structural engineering, what all innovations do I see happening is, of course, this that I just said, it's still the damper technology, right?
Yes.
It's still, I think, not even adopted in 0.001% of the buildings.
In this country?
In this country. We're not even talking one city or... so let me put it this way. Ahmedabad has no building with this technology.
Why so?
It's just that, one, I think the confidence on the technology.
Yeah.
And the second is, that general mentality that I should not be the first one.
Yes.
Let others do it. I'll learn from others.
Yeah.
Others is success or others is failures. And that's a mindset which always kind of pulls us a little back.
Right.
So, yeah.
Utsav, how do the buildings for like 100 stories, Dubai mein Burj Khalifa, all the tall buildings everywhere, Dubai, Hong Kong, some parts of India, वो लोग क्या करते हैं? आपको पता है ऐसे, for a layman, अगर आप जा रहे हो कि construction हो रहा है, and I see, wow, इतना deep खोदा है, बहुत strong building है.
Wow.
That's what you think, but what exactly goes in making a building strong?
So that's a very, very tough question. I mean, I was just kind of talking to someone recently, and the guy kind of asked me that is the strongest structure that you have kind of seen.
Very basic question, but yeah.
He was not a civil engineer.
Yeah.
Okay. What is the strongest building on this planet, on this earth? The answer was very straightforward. There's no such thing as strong. And I would probably end up saying that the forces that be, the forces that come, all our job is to just understand gravity, understand those forces, and design each element for those forces in the optimal and the right manner. There's no such thing as strong.
So that's nature. How do you define and
Exactly.
understand nature?
And that's where, I think, I'll tell you, the interns that come to our office, a lot of the times I kind of explain them in a simple way. In fact, when my brother was growing up, and he also is a structural engineer, I explained him in a very simple manner that every single element of your body, I can explain you a structural phenomena through that. And the stresses in every single joint, say if I'm extremely overweight, right? Suddenly after a month or two or a couple of years, your knee starts, right? Why does that happen? That kind of gives me a clear indication that probably the load above has increased so much that my foundations or my columns
Not able to take
are not able to take that anymore, right? Now, does that mean my legs are weak? No, my legs were never weak. In fact, they were always what it was, just that the load increased somewhere else. So I just need to ensure that whatever it is, that I have, the loads acting on it are manageable. So I need to now reduce my weight. That's essentially
But
what
then,
I'm trying
coming back to the question, how do these tall buildings, what do they do? What technologies do they use?
So you'd be, surprised that not all tall buildings have technologies. And yes, Type 101 and a lot of some other interesting structures across the world have other forms of dampers. in it.
Okay.
So essentially, there are more than 15 to 20 type of different dampers, each suited to the type and the height and the aspect ratio of a building. And what a structural engineer's real role is when designing such tall buildings is less of an earthquake, more of the wind. Now, wind plays its music in a very different way than earthquake does. I think if you look at all the major top tall buildings across, say, New York or Dubai or anywhere else, you will see these different forms of dampers really coming into picture. So that's, I think,
actually comparing a wind and an earthquake. So
yes,
what role does a wind play?
wind becomes extra.
We never even think about that.
Exactly. So again, I'll come straight to where we are. As in Ahmedabad has just started, in its journey to build tall buildings.
Yes.
It's still at its nascent stage.
Yes.
But
we're getting there.
But we're getting there, and I hope to see more happening here. But as we've started this journey of building taller, we are seeing that people are sensitized towards wind as well, because even a small vibration or a small oscillation in wind can cause a lot of discomfort while we are talking and sitting. If this building was to oscillate in wind, because
so a building oscillates.
A building oscillates. A building moves. There's a frequency of a building to which it even resonates, right? So it's a very important and critical aspect of a structural engineer's job, is to understand the frequency of the forces, the wind forces, and also the frequency of your structure. And if both of those match ever, God forbid, you are in deep trouble. And that's
super.
Yeah, it's super mathematical, right? So again, nature's forces against the man-made resistance. Essentially, that's what we do.
After earthquake, have people started taking structural engineers more seriously? The Gujarat earthquake I'm talking about, 2001. People look at you differently?
I don't know that really for sure, but I would like to believe that at least the fraternity has started giving
More
respect and more importance to what we do. And I think
I assume even a layman would understand your work better.
I would like to believe that, but then, like I said earlier, a layman still needs to get a lot of education on what really is structural engineering and what really goes into a concrete building.
How is your practice evolving with changing climatic conditions and environmental concerns?
See, there are two facets to this. One is, how can a structural engineer bring in sustainability aspect to the construction, and the other is, how is the change in climatic conditions impacting my work.
Yes.
I personally don't see any major tectonic shift in how I operate based on the current climatic conditions or the changing global warming aspects or any other. But then, yes, if I were to kind of say that, are there repercussions on what could be the future for us? Yes, there is. As the sea level rises, right? The first thing you would ask is, how do I protect my low-lying areas? Go and ask Amsterdam how they did it, right? Amsterdam and probably the whole of Netherlands, right? It's way below the sea level. They end up creating huge mud walls to kind of protect and keep the sea at bay.
Really?
Yes, and it's the most fascinating piece of.
What are those walls made of?
Different materials, natural earth, steel, concrete. It's a combination of all these materials. Again, the beauty is how do we take this material and engineer it and even forecast that problem, right? I think the problem here is not of engineering, but the problem is forecasting what could be the problem. right? And I think the engineers out there have done a stellar job. And as we kind of move into that, realm of engineering, hopefully not in the next 50 years, but who knows, we would see a lot of those protection structures also coming into picture. And again, as we build deeper and deeper and deeper and deeper, because we just can't stop producing cars, can we? So more car parkings, more excavation. Where do we dump that soil? How do we protect those deep excavations so that something adjacent doesn't fall by? All these aspects also play a very critical role in what we would end up doing as structural engineers. So yeah,
long way to go. Yeah,
long way
So
to
much
go.
to look forward to.
We may not encounter those problems immediately, but we still have to be equipped with that.
Yeah.
Yeah.
I wanted to ask, what's the biggest misconception about structural engineering?
So the biggest misconception, I can't say it as a misconception. It's just, again, people just like you said, वो बड़ा बड़ा सलिया क्या होता है, right? Like essentially a lot of the misconception starts from the fact that people kind of used to perceive, or probably some people still do perceive, ये सलिए वाला है. So I mean, and that's not really it. अच्छा, आपका काम क्या है? वो सलिया देते हो, वही ना, आप सलिए वाले.
चलिए वाले हो, हाँ.
तो
सलिया भी बनाते हो आप लोग?
हम सलिया ना बनाते, हम सिर्फ उसका इंजीनियरिंग करते हैं. बनाने वाले बनाएंगे, रखने वाले रखेंगे. तो
कितना बड़ा होना चाहिए, कितना क्या होना
हाँ जी.
चाहिए, हाँ.
But then we very humbly acknowledge sometimes, हाँ जी सर, हम सलिए वाले.
सलिए वाले.
बरोबर.
एंड उत्सव, जो बड़े बड़े आजकल रूम्स होते हैं, आपको बिल्डर्स बोलते हैं कि हमको ये पैनोरामिक व्यूज चाहिए और हैंगिंग बैल्कनी चाहिए, जो अभी हम बात कर रहे थे. तो डज इट बिकम चैलेंजिंग फॉर यू ऑल? तो वो कैसे, वो सलियों का डायमीटर बढ़ जाता है?
Yeah, I mean, so again, everything is not steel and everything is not reinforcement. We do have to engineer that in a very thorough manner. Concrete sections बढ़ाने पड़ते हैं. कभी कभार अंदर post tension cables डालने पड़ते हैं. Those are cables which are kind of inserted within the concrete, and then once the casting is done, you kind of stress that cables so the whole slab kind of lifts. So again, a lot of the technologies kind of go behind doing such demanding aspects of our field, and I think today, credit to all these technologies, the architects are getting a little adventurous as well. Right, that they want the smallest sections of the structure, but they want the biggest spans.
I can visualize structural engineers and architects having this heated discussion about, I want this not possible, stuff like that.
Oh yeah, we go through that on a daily basis. But then what we've learned is, as part of that debate, how do we crack a decent joke? So it doesn't really.
एक ही project पे काम कर रहे हैं, मिलके कर रहे हैं.
So I do feel that sense of humor is very important for structural engineers to kind of still have, because things can get really heated up in these discussions.
And this industry, आप लोग ज़्यादा same लोगों के साथ काम करते हो ताकि वो camaraderie already होती है, understanding होती है. Does it get easier if you've worked with somebody?
Of course. I mean, see, I've been working with all these developers and architects for years and years, but then we as structural engineers also always look forward to working with new architects and new developers, because through them we kind of learn a different facet of demands and expectations. Right? I think for us it's very important to keep on learning and evolving by working with lot many people.
Right.
You kind of work with a few people, you get stagnated.
Yeah.
Right?
So multiple diversity, you need to grow. Yes.
Diversity is the key for any evolution. So for us, that's the same.
I have this question.
Yeah.
Wherein, जैसे ceiling से जाते हैं और ceiling पे वो जो bridge बनता है, you always wonder कैसे, मतलब समंदर का पानी, waves, salty water, कैसे बनाए होंगे ये pillars and to be certain. it just seems unreal.
It is
उसके अंदर मतलब समंदर के अंदर आप roads बना रहे हैं. Everywhere in India, you talk about Bombay.
extremely fascinating. I mean, and they kind of create huge caissons, kind
Yeah.
of keep the water apart. Humans kind of go in that area, dig the pylons, and it's just amazing piece of engineering, right? Like so, that's all part of structural and construction engineering. So, I mean, I don't think I'd give credit only to structural engineers there, because structural engineers do have a role there, but credit to the construction engineers.
Okay.
Those guys, such phenomenal. And I do feel extremely, proud that there are such, amazing contractors and skilled civil engineers who kind of do this
Yes.
crazy work.
And so much of science must be going behind this to understand chemicals and how the chemicals react to each other.
Absolutely. It's crazy to kind of even imagine that, you're working in salty water and then ensuring that structure kind of stands for 100, 150 years.
Exactly.
Right?
It's not just for a month.
So then that's where structural engineer, construction engineer also need to learn about chemistry.
Yeah.
So one part of our job is physics, which consists of gravity. The other part is to understand chemistry of how concrete works, chemistry of how different chemicals work with concrete, chemistry of how those chemicals react to reinforcement, right? So the metallurgy part of it, we kind of have to encapsulate all these components in our engineering and knowledge gaining process. It kind of comes with experience as well.
Respect to all the structural engineers and the contractors, and of course along with the builders and the architects. Absolutely. Utsav, you want to share with us like one interesting or a fascinating part that as an audience we would not know and you'd like to share?
Let me ask you, actually, if there's a structure here, if this is the slab, you kind of see a crack here somewhere, small crack. You kind of get afraid, right? Oh, this is going to crack, this is going to break, this is going to fall down. Right? Now, yes, most cracks are bad. Not all cracks are bad. So it's again something that, like I said, I always hesitate in explaining it to everyone. But that's one thing that I would like in future to kind of educate people on, that not all cracks are bad cracks. Some cracks are required. Some cracks happen so that stresses and forces get relieved, right? Again, concrete is a brittle material, right? You can engineer it as much as you want to and as much as you can, but any brittle material can have some degree of cracks, right? But how do you handle that? How do you encapsulate that crack, or in your engineering, in your forces? You do need to do that homework. But then, that's one future aspiration that I have, is to kind of work on cracks, and which is absolute basic thing, right? It's a absolute grassroots level work that I would like to do in understanding and explaining more
to people. Yes. Are you set for a quick rapid fire?
I'm not sure.
Not sure?
I'm still not.
Come on, go ahead.
Okay, yeah. Let's go about it.
Steel or RCC? Your go-to material?
Yeah. So RCC is obviously an extremely versatile thing, and it's been the workhorse of Indian construction industry. But as we keep building at this breakneck speed, I do feel that steel and composite is going to be the future.
Residential, commercial, or institutional? Your favorite place?
100% institutional. 100% institutional. I mean, I think the creative freedom, the experimentation, and no limitation structure and architecture, right? And you kind of get the best structures in institutional. Hands down, it has to be the institutional.
I agree. I agree. One engineering software you can't live without?
I mean, we do use a few of them, but ETABS, SAFE, Stat Pro, RISA, I mean, these are our daily tools that we can't live without.
We haven't even heard these names. We're just asking this question. It's okay.
Yeah, beautiful names though. ETABS, RISA.
Yeah, sounds fancy.
SAFE. Beautiful names.
Most challenging structure you worked on?
The challenge is kept on changing every time I kind of grew in experience, but in my recent memory, the most challenging was the aquatic museum that we just did at Science City.
Okay.
I think that has to be hands down the most challenging structure that I have been part of so far, and where we ended up designing acrylic as a structural element. There are sharks, there are penguins, and everything right there. You should go and check it out. And of course, it was less of a structure, more of a water tank, and to be able to kind of be part of that kind of a structure, it was a once in a lifetime kind of a structure.
I can imagine how I feel like going there, and once I go there, I'm sure all of us would have a structure in mind along with the penguins and the sharks.
Yeah, it's a beautiful, monument for Ahmedabad. I think it's our dedication to Ahmedabad.
Most underrated aspect of structural engineering?
Gravity and physics, always work in a unilateral direction. I mean, I think sometimes people kind of fail to understand gravity, and that's the most underrated aspect of structural engineering. So gravity, and basically what that translates to is there's a load path. मैं अगर खड़ा हूँ तो force तो नीचे ही जाएगा, right? Gravity cannot change itself. Now we're not talking about interstellar kind of discussions here, but then gravity on Earth is always down, and loads and forces need to go down. Things need to be connected in a certain proper manner, and that's how you make the structure stand. And it's a very easy thing to really understand gravity, but then I still see that young engineers kind of fail to respect gravity a lot of time. And I see a lot of experienced professionals also sometimes missing out on that.
And it's very relevant figuratively and literally both, and philosophically if we think, it applies to life as well.
Yeah, exactly. Respect it. Yeah.
One common design flaw that you often see in designs?
Columns and beams and foundations are supposed to be married to each other in a nice, nice marriage. Right? Like they're supposed to be together and like each other. You kind of, I still end up seeing, in perhaps some buildings that, things that are supposed to be married are not really married, and that's where really the problem starts in terms of the longevity of the structures. And again, coming back to my previous answer, that's where physics and gravity don't really, kind of say a yes to what was done.
Your architect friends are going to come to you now.
Well, they love me because I understand gravity, but then I would love that they love me more.
One thing that instantly impresses you in a young engineer?
So, the ability to ask why rather than how. You know what I mean? I mean, when an engineer asks, me or any of my senior team members, why are we doing this? Right? How is just a method. Why is basically the premise of understanding the larger aspect. So if we see that there's a decent whys in the question, that's
nice.
kind of
and sometimes even seniors haven't asked the whys
in a long
question
time.
Yourself.
Yeah, they did it when they were young, but then they've stopped asking.
Agreed.
Right? So yeah.
Ahmedabad skyline in one word, according to you?
Definitely emerging.
One city in India with inspiring structural design?
Delhi. I love what Delhi has kind of been able to do and has done in the past.
Gurgaon? Noida?
No, I entire of NCR. I mean, you look at the brilliant institutional projects, sophisticated architecture, brilliant structural engineering. I think, and not just the recent ones, even the ones that were built, say, in 60s, 70s and 80s, inspiring structures. And I think going to all the bureaucratic and government circles out there. Obviously, that's also where India gets shown the first, and
Yes.
probably that's the reason why it has always had that.
So Delhi deserves that.
Delhi deserves that, right? More than anything,
Yeah.
Delhi. But then obviously that kind of spills over to Noida and Gurgaon as well, right? It goes without saying. I still do feel that Hyderabad is emerging as a brilliant city, and I mean, Bombay is obviously amazing. Bombay is amazing, but definitely Hyderabad is really kicking.
I have been hearing so much about Hyderabad in terms of
the type of work that's happening, the innovation that's happening, the crazy architecture that's happening. So yeah, Hyderabad, I would put my money on Hyderabad as the future big mega city of is already there, but
but still,
competing with Bombay. Yeah.
What's always in your car when you're going to visit sites?
Oh, you'll be surprised. So it's basically when I visit sites, I just have a couple of papers and sheets of some drawings and some calculations. Otherwise, essentially, it's just me and my thoughts, and that's it. While going to the site, I always do a lot of prep, and then most of the other times I'm on the call, because that's where I finish most of my calls. Yeah.
Utsav, this was a very enriching conversation, and thank you so much for articulating it in such a way so that everybody could understand. And structural engineering, such an important aspect of any building.
Yeah.
You need to talk more on it, be the face of it.
Really, you think? I mean, I would love to kind of be an advocate for the whole fraternity, but then yes, I mean, large part of our fraternity is still very much behind the scene, kind of doing the job, and
we need some torchbearers like you,
and let the others take the limelight. I mean, I think that's where it's the best and the happy space. Yeah, exactly. Limelight is not our cup.
So
yeah,
but wonderful. Thank you so much
Brilliant.
for your time and for everything.
Thank you so much.
No, bye.
Appreciate it. See you.